everyone, this is lesson 2, session 2 of our lesson on finding the area of a triangle. I'm going to read the problem below. You guys are going to try the problem, and then the second half of the video, I will be explaining how to solve. So, it says on page 25 of your math books, read and try to solve the problem below. Maria's class is painting a mural on a school wall. Staff at an Acoma Cultural Center helped Maria copy an Acoma Pueblo pottery design to use in the mural. Maria draws her design on 1 centimeter grid paper. She begins with one of the triangles. What is the area of Maria's triangle? Before we start to solve, we want to find what is important about this word problem. We want to do this every time we have a big word problem like this. Find our information that's important. So I'm going to read it again and I'm going to take a couple notes. Maria's class is painting a mural on a school wall. Staff at an Acoma Cultural Center helped Maria copy an Acoma Pueblo pottery design to use in the mural. This is mostly background information, right? I don't really need this for the math part of my problem. This is just telling me what's going on and why we're trying to solve this. Then it says, Maria draws her design on 1 centimeter grid paper. This is a measurement, so this is important. It's also talking about my grid paper, so I know I need to use this picture to solve. This 1 centimeter is telling me that each of these boxes is 1 centimeter in length. Then it says she begins with one of the triangles. So I know we're using triangles. That's going to be important. I need to know what to do. I need to think about how I'm going to work with my triangle. And then there's a question. What is the area of Maria's triangle? So now I know what I'm looking to find, right? So right away, I know I'm looking for area, and the area formula that I do know is area equals base times height, which is what we use to find the area of parallelograms, shapes that look something like this. Remember that this equation does not work for triangles. You guys right now that you've read the problem, you're going to read the problem again, you're going to pause the video, and you're going to try to do this problem on your own. After you've tried the problem in the space below in your workbook on page 25, you're going to come back to the video, press play, and we'll talk about how to solve this problem. All right, so if you're back, you've just tried your problem, and now we're going to go over it. So let's take a look. I'm going to read the question one more time. Maria draws her design on 1 centimeter grid paper. She begins with one of the triangles. What is the area of Maria's triangle? So like we just talked about, like I just mentioned, we're not able to use this formula for this triangle. So what we need to do is make this triangle into a parallelogram, right? What we want to do first is decompose, right? There's a vocab word, our triangle into a parallelogram. Once it's a parallelogram, I can use my base times height formula. So I want to decompose our triangle into a parallelogram. To do that, and to show you how to do that, I'm going to switch over here to my example triangle. This is the same triangle that you guys have in your workbook, just remade and on a whiteboard. So we're looking at this triangle, and I need to decide how to make this a parallelogram, right? I have a triangle. I need to decompose my triangle so that it's in the shape of a parallelogram. How am I going to do that? Well, first thing I need to notice about this triangle, and it's a little bit easier to notice this closer up, is that if I'm going to make this into a rectangle, I want to make it as easy as possible for me to do that. So the first thing I want to do is think about where can I cut this triangle into pieces to start forming a rectangle. Take a second to just look at this picture and think about where does it make sense to cut the triangle? Is it here? Is it here? Is it here? What part of that triangle looks like it's already starting to form a rectangle for us? Pause the video and think about it for a couple seconds. Okay, so if you've noticed, cutting off the triangle here is not very helpful because that leaves us with half of a box, which is going to be kind of hard to fill in. So I don't want to cut my triangle here. Here I have half boxes. That's not very easy. Up at the top, same thing, right? It cuts off halfway through these boxes, and these boxes are all cut off. So that's not really easy for me to make a rectangle. However, if you're looking about here, right, we notice that these form perfect boxes. It looks like there's a rectangle already starting to form. So I'm going to cut my rectangle right here. Okay? And then, because it's the tip, the second line we want to cut, the second place we want to cut is from the tip of the triangle, the top vertex, straight down. And I'm going to cut my triangle into pieces like this. And to better show you what comes next, I'm just going to replace these tiny segments of my pink triangle with some little colored pieces. So it's the same triangle, nothing's changed yet. We just want to be able to see a little bit better how we've cut our triangle up. So now I've cut my triangle into this kind of odd looking, almost rectangle parallelogram shape, but it's missing some pieces here, right? It's also missing some pieces here, which we just talked about. But right here, I could nicely cut it across the top so that my rectangle on the top ends with some whole pieces. There's a whole segment here, and there's a whole segment here. So what are we going to do now to finish making our parallelogram? Take a couple seconds to think about how can I move these pieces to make this a full rectangle. Pause the video and think about it for a couple seconds. So one thing I can do, right, we talked about flipping our triangles, flipping our shapes, so that we can manipulate them, so that we can decompose them into other shapes. So I've decomposed my triangle into these shapes. Now I want to see how can I move them around and arrange them. And what I'm going to actually do is I'm actually going to physically cut this for us to see this even a little bit better. So now our triangle looks kind of like this, right? Same triangle, same idea. Just wanted to cut that top part off. So you'll notice that these shapes, the orange and the yellow, are the same exact size of this top part that we just cut off our triangle, but now it's easier for us to manipulate. So I'm noticing that this area right here seems to be about the same exact size and length of this area right here. Hold on one second. Okay, sorry for that glitch. I had to plug in my laptop. It was going to die. So I was saying, we can notice that this side of my triangle looks exactly like it's the same length and size as this one right here, right? And now that it's a shape, I can actually move this around to see how do I want to add this shape onto my bottom base of my triangle to make that parallelogram. That doesn't really make a very good shape, so I'm going to turn. Let's see, that is not going to make us a very good shape, so I'm going to keep turning until I notice that that fits perfectly right here. Now I'm going to look at my yellow one. I notice that this side of the the base of my now cut up triangle looks to be about the same size as this piece right here, right? Just from looking at it, I observe that they seem to be about the same. I don't know for sure. I'm going to find out right now. So the same thing I did with my orange, I'm going to manipulate this triangle to see if it fits perfectly in the base of my triangle, and it looks like it does, right? So remember, here's our top of our triangle again, that our orange piece and our yellow piece together, composed together, make this shape. And when we cut them up into pieces, we were now able to manipulate them and flip them down to make this rectangle. Cool. So now that I have my rectangle, I can use my formula, A equals base times height. And I'm saying rectangle because it is a rectangle, but of course a rectangle is a parallelogram. So either of these words work. Now that I know I can do A equals base times height, I need to find my base and find the length of my base. So I'm going to count 1, 2, 3, 4, 5, 6, 7, 8. And I need to find my height. I need to find the length of my height, 1, 2. And now I can solve my equation. Area equals base times height, which is going to be, in this case, 16 centimeters squared.